machine learning. Now, this will comprise two parts. One will be the theory part, where we'll be explain what is machine learning and how it is basically the various types of machine learning data models. Then we'll dive into what is automated machine learning, which is very relevant for core engineering students today. And then finally, we will get into a demo, where Kiran sir will come in and he will demonstrate few use cases in the electrical and electronic space, right? So let me just share my screen. Okay. So basically, we are going to talk about what is AI. We are also going to dive into what is machine learning and what is deep learning. We will talk cases that is applicable in the electrical and electronics engineering space. We'll get into AutoML, how AutoML is useful and why it has become so important today in the industry. And then we'll get into a hands-on demo, right? So what we will do first is, I wanted to understand from, ma'am, how many students are there? 1 minute. Oh, 200 students. Okay, very good. So first of all, I just wanted to ask one basic question. What is AI? Can anybody, you can put it on chat. I just wanted to hear from you, what do you mean by AI?
It's an artificial intelligence.
That is the full form. But what is the full definition of AI? Hear this word AI pretty often, right? Any student, anybody, what is AI? Okay. So AI in very simple definition, and please, I would request all of you to participate, right? Because it's important that I know how much you know, right? So it is the ability to perform human tasks. Yes, Charita, very good. Human machine face. What is human machine face, Charishma? Ability of machine to perform tasks. Okay. It is the ability, but why we are talking of, why is it called artificial intelligence? So one, as Charita said, yes, performing human tasks, perfect, that is right. What else? So basically we are talking about simulating human behavior, right? So what typically a human being would have done, we are asking machines to do that, right? Whether it's robots, whether it is robotics, machines which are in various manufacturing plants across, you see various companies today using robotic machines to do various types of operations, right? It helps in making a human work easy because of working like a human by training the models like human nerves. Okay, fine. Simulating behavior. Okay. Now, does anybody have any idea what is machine learning? Does anybody have any idea what is machine learning? Even if you don't know, it's fine. But based on your knowledge, I'm sure you must have heard this word so many times, and you must have at least done one Google and find out what is machine learning. Anybody? But these are very, very important terms in the industry today, irrespective of what industry you are in, right? And I thought I'll just get an insight. I mean, you may not know, that's okay. But anybody has any idea? Okay, so I will get to that. Now, what is machine learning? I will explain you with an example, right? See, first of all, when you talk about machine learning, the first and most important thing is that for machine is you're asking a machine to learn, right? Now, what is it you're asking the machine to learn, right? So you are asking the machine to learn data, to basically basically to understand the data. Okay, the main important thing in machine learning is you need to have historical data. Okay, that is very, very important. You need to have historical data. Okay, And I'll explain you with an example of what do you mean by historical data. Okay. Now, for example, let's say you have you have joined a company, and when you join a company, obviously you're going to get salary, right? You will get some salary, and there is a department in the company which is responsible for giving salary, and that department is called the HR department. Okay. And the HR department keeps information about every employee who joins the organization, his demography, his name, gender, uh, address, everything. Plus, we also store some information about his years of experience. Means how much? I mean, he must have come fresh from a college, or he must be a lateral. That means he must be work. He must have worked in some other organization. Now he's come into a current organization with some 2 years, 3 years experience. That's we call lateral person, lateral entry. So we have years of experience and we have salary. I'm just taking two important fields. So I will, for every employee, I will keep an information of, okay, he has got so much years of experience and is the current salary he's drawing. For another employee, have current years of experience, so much salary is drawing, right? And suppose I've got around 1,000 records. Okay. Now, the company tells me that can you come out with a machine learning model? Okay. We use a word called model, which is as good as basically an algorithm, nothing else but an algorithm or a program. When you hear the word model, it basically means an algorithm or program, right? So first of all, what happens is, first of all, you need to have some historical data. Now the HR department wants us to come out with a machine learning model with this data, with this specific set of data, which has around 1,000 records. Okay. So what we do first is, once we have a historical data, you feed this data into an algorithm. Okay. Now this algorithm, what it does, it tries to generate a pattern from the data. What it will try to do is, it will try to see if there is a relationship between the various columns in the data, right? Let's take a simple example. For example, if you have wear a shirt, right? When you wear a shirt, there's a certain pattern in the shirt, right? You have a particular, you will have some stripes, you will have some lines, and various types of features which are there in your shirt, right? So any costume, you will have some features, right? Similarly, when you have a particular animal, like say you will have, or any human being, you will have a particular features, right? When you have a cat or a dog, they will have a specific features by which a machine can identify, right? So for now, I'm just telling you there is some 1,000 records of years of experience and salary. I take this data I feed it into an algorithm. The algorithm will go through the data and will try to generate a pattern from this data. Now, based on your understanding, do you think there is a relationship between years of experience and salary? Do you think there is a relationship between years of experience and salary based on your logical thinking?
Yes, sir. Yes, sir.
Yeah. So, what is the relationship?
As experience increases, the payment should be more to that person, sir.
Very good. So obviously this is very common. I mean, we all know that obviously when you work in an industry, you work, as your years of experience increases, you get incentives, you get bonus, you get promotions, and so on. Obviously, unless it's a very it's a very unavoidable situation. Most of the cases, you will have with years of experience, your salary will also increase, right? So this algorithm will try to derive a pattern based on this data. Okay. Now, once it has done the pattern recognition, okay, now if I feed a new set of data, I feed a new set of data. For example, when I feed the years of experience, when I feed a new data which is not there in your data set, which is not there in your original data, when you feed that new set of data into the machine, now what is happening is the machine has already learned based on the data it has already gone through. It has realized that there is some pattern between the data. There is some pattern. Now, based on that pattern it had recognized, it will try to predict. It will try to predict the salary. So what I'm saying, you have got some records, you have fed that records, historical data into a machine. The machine will derive a pattern out of this data. Based on the pattern it has recognized, the machine has, based on the number of records it has gone through and the pattern it has recognized, it will be able to predict the values for a new set of data. So if you enter a new years of experience which is not there in the original data when it was trained, it will automatically predict the salary. Okay, and this predicted salary should be close to the actual salary. This predicted salary should be close to the, or should be as close to the actual salary. Okay, and once we come to this stage where your predicted salary is very close to the actual salary, then I say the accuracy of the model is good enough to implement. Now, typically in the industry, when I say accuracy, accuracy typically in the industry will be 90%, 85, more than 85%. But generally, you will never get 100%, right? Unless it is the problem, unless it's a very unique situation. In 99% of the cases, you will never get 100% accuracy because it is ultimately a machine. But today in the industry, there is a benchmark which says that if I have an accuracy of a model more than say 90% or 85%, I have that understanding with my customer. In that case, I can say I can deploy that machine. Third, we are talking about prediction. And based on the prediction, we find out the model accuracy. Now, this steps is basically called machine learning. So, any application of today, when you talk of any application of today, okay, we'll go through some applications. All are based on this concept. Everything is based on historical data, pattern matching, and deep prediction. Right? So, this is how the industry is moving today. So anybody has any questions on what is machine learning? If you are clear, please put a yes on the chat box. If you have understood, please put a yes on the chat box.
Sir, I have a doubt.
Yeah.
Whether this machine learning uses the internet also to get this pattern matching prediction model?
It uses algorithms. So there are algorithms which are there, which are programs, which will go through the data. So the data can be from anywhere. It could be a streaming data, it could be an Excel file, it could be a PDF file, but it is an algorithm which goes through the data and tries to derive a pattern.
Okay, sir.
The pattern has to be detected by the algorithm. Algorithm is a program. It's a statistical based programs. Does it answer your question?
Yes, sir.
And please tell your name and whether you're a faculty or a student, right? So I think you're a faculty, right? Please tell your name before you ask a question so I can understand. Yes, okay. So is this definition clear to all the students? Can I get a quick yes or no on the screen? If you have understood, I think all of you are there. There are how many participants are there? 255, big number. Good. Anybody? Okay, good. People have understood. Kiran, have you joined?
Yeah. I have joined, sir.
Okay, very good. Okay, thank you. So, yeah, Kiran, you can go on mute. Yeah. Fine. So, Kiran sir has also joined. Okay, thank you, Kiran. Fine. So, now you have now understood the basics of machine learning. Now, how it is implemented in the industry. Let's get into that. So first of all, when you're talking of machine learning, there are some, when you do a project, there are various steps in that. Okay. Now, number one step is that, first of all, you need to get the historical data that you already know. Okay. Historical data is a must for the machine learning, for basically machine learning. Now, once you have a historical data, the number two, what you do is we do some called a data pre-processing. Now, what is data pre-processing is, for example, your data which you're having, first of all, the machine learning data that you have, first of all, should be perfect. Perfect in the sense there should not be any null values. So first of all, you should not have any null values. Okay, you should remove all the null values, right? Either you should replace it with some value, or you can delete that particular row which has got null values. Okay, now that is number one. Okay, number two is that all the values in a machine learning model, before you feed it into a machine, have to be numeric. They have to be numeric. You cannot have a country name or something like in your model, right? You cannot have any country name. It has to be converted into some numeric text. So we're not getting that details, but just remember that any values that get into a machine learning model or algorithm has to be numeric. Okay. And third important thing is, once you know your data is perfect, the data is clear, clean, data has no problems. What you do is you split the data into training set and test set. Now, let me explain you this. Now, we saw, ma'am, can you please go on mute? Now, we talked about this HR department, years of experience, right? Now, when you are going to, when you're this is your data. So this is your historical data, which has got 1,000 records. So in your data pre-processing, first of all, you have to remove all the null values. You have to ensure all the values are numeric. So there are ways to do that. Okay. And now what you have to do is you have to split the data into training set and test set. Okay. Now what does that mean? Now you have to decide. Now typically industry, I will say it minimum is, that's how it is. It should be minimum 70%. So your minimum 70% should be for training and 30% for testing. Minimum. It could be 75%, it could be 80%, but generally minimum 70% should be training. So that means I have 700 records for training set and 300 records for test set. Okay. So what I do is, now I split that 1,000 records. I make it 700 records training set, 300 records. So next step what I do is, the modeling phase. What is the modeling phase? Now I'm doing is I'm taking the 700 records, right? I feed it into the algorithm. What is the purpose of feeding into the algorithm? To derive a pattern. I take the 700 records, I feed it into the algorithm, and I try to derive a pattern. This is called the modeling phase, right? The next phase is called the evaluation phase. Okay, so what I do in the evaluation phase is, now that the machine has been trained with 700 records, you have the years of experience and salary. These are the two fields which has got into the machine, and you are able to derive a pattern. Now you take the remaining 300 records, which is your test set. You take the remaining 300 records, which is there in your test set. And what I do is I take the years of experience field. Now remember here, I am not taking the years, the salary value here. I am taking only the years of experience value, okay, for evaluation. So I take the years of experience field values from the 300 records test data. I feed into the model So now the model has been trained with 700 records. It knows the pattern. It has derived some patterns. And based on when you feed into the model, it will come out with what is called a predicted salary. Okay. Now, once you have come out with the predicted salary, I will compare the predicted salary with the actual salary. Now, this actual salary data is already there in the 300 records. Remember, when we had taken the 300 records, we had not touched the years of salary. That is the actual salary. We only touched the years of experience. And based on the years of experience value which had fed in the model, I basically compute or find out the predicted salary. And now I compare the predicted salary with the actual salary of the 300 records. The 300 records actual salary. So if the predicted value is close to the actual value, which means my model accuracy is high. Otherwise, I need to look at some other algorithm. So as I told you, generally the benchmark in the industry is 85 to 90%. So if my accuracy is exceeding that benchmark, that means I'm good. Otherwise, I need to relook at some other algorithm or model, right? So once if I get a model, what is the purpose of the HR manager to do this exercise? The idea is that once he gets a model which gives you a very high accuracy, he can generate a letter, a recruitment letter for the candidate automatically. Okay, he doesn't have to type it. It will get automatically generated, right? Because the machine has predicted what is, okay, if he has got so many years of experience, this is the sort of salary I should give. It will auto-generate a letter with the values, and it can be sent to the prospective employee. Okay. So this is how machine learning, I'm just giving an example, this is how it is implemented in an industry. Right? Any questions on this? Have you understood how a machine learning project is implemented in an industry? Please press a yes if you understood. Can I get an acknowledgement on the chat?
Yes, sir.
Okay, great. 255 students, only two or three students are responding. Of course, I'm obviously assuming faculties are also there. So I'm sure there are not 255 faculties, and but I request at least some of people you have to respond. Yeah, so good, Miss Lakoshi, very good. See, if you're not understood, I don't mind repeating it, because the challenge out here is if you don't understand this concept, when Kiran sir is going to show you a demo, you will be lost. So I'm spending a lot of time with you guys for you to understand the basic concepts. If your basic concepts are clear, it is very easy for you to understand the demo aspect as well. Yeah, very good. Okay. Now that you have done this, now I have come to some additional points, right? So now, as somebody rightly said, okay, you have got AI. Now, machine learning is a subset of AI. That means it is part of AI, right? Now, the next most important term is we need to understand what are the various types of machine learning models or machine learning types. Okay. So there are two types. First of all, what you call is supervised learning. And unsupervised learning. Now, there is something called reinforcement learning also, which I will not discuss here because that is very more complex. But for now, let's focus on these two areas, supervised and unsupervised learning. Now, what is a supervised learning? Okay. Now, typically when you have the data, historical data, the data will be in a particular format. Okay. Now, assuming that your data is typically a y is a function of x. Typically, or how the data will have. Okay. So, for example, if you have a equation y equal to mx plus c, where this is a typical straight line, right? You could have a straight line. I'm looking at a very simple example: y equal to mx plus c, right? Now, what is y? We all know this is in algebra. Y is a y-axis, x is your x-axis value, m is the slope, and c is the y-intercept. Right? We all know this, right? Now, what does this mean? X is dependent on, sorry, y is dependent on x, right? So if x increases, y will increase if your slope is positive. X, if your slope is negative, when x increases, y reduces, right? So you have a inverse line, right? Either you have a linear straight line, okay, or you have a reverse line. Now, when you come to machine learning parlance, assuming your data is is in this format. Now, this y is called output. It is also called dependent variable. While x is called input, is also called an independent variable, and sometimes it is also called feature. Okay, feature, or it is also called a predictor. There are various terms used today in the industry, right? So y is your dependent variable and x is your independent variable. Now let's get back to this. Let's go to this equation. Now coming to this particular equation, can you tell me if you fit this in that y equal to mx plus c equation, can you tell me which is the dependent variable and which is the independent variable? From years of experience and salary, can you tell me which is the dependent and which is the independent variable? Years of experience is independent variable, okay, and salary is your dependent variable. Very good, right? So because your salary depends on years of experience, and it's not the other way. Okay, it's not that the years of experience depends on salary. Your salary depends on the years of experience, right? Okay, so very years of experience is independent, salary is dependent. Very good. Salary is dependent. Yes, yeah. So you have salary is your years of experience, and which is your salary is your dependent variable, and years of experience is your independent variable. There's a noise coming actually. Can somebody eliminate this noise? Thank you. Yeah. Okay. So now you have understood what is a dependent variable and what is an independent variable. Okay. Now when you come to this machine learning aspect, okay, where is it called? Yeah. Now when you look at this equation y equal to mx plus c, okay, this equation is called regression. This equation is called regression. Okay, generally in mathematic terms we use the word algebra, we call it regression, right? Now what is regression? Now there are two types of regression. Now first of all, I'll come to what exactly is regression. Now in the case of regression, your y is having an indefinite value, or we also call it is a continuous variable, which means that it could have any value. For example, when I say salary could be 10,000, 20,000, 30,000, 1 crore, 1 lakh, and so on, right? It could be different depending on the years of experience. So your y or dependent variable doesn't have a fixed value. It is a continuous variable. Okay, when it is a continuous variable, we call it a regression model, regression data type, regression data. Yeah. So you have a regression type, which is your data, which is having a dependent variable, which is a continuous type. It is not a fixed type. It is a continuous. It could have any value.
So
Okay.
your presentation has stopped.
No, I'm showing the notepad. No, can you see my notepad?
No, sir, it's not visible.
Oh shit! Why? Sorry. I don't know why it happened. Give me 1 minute, man. Sorry, I don't know why it happened. Thanks for pointing out. Are you able to see now? I hope this was visible to everybody.
Yes, sir.
Okay, this was visible to you, all right? Okay, fine. So when we are talking about an indefinite value for y, we call it a regression. So regression, there are in regression, now we have something called a univariate regression, where there is just one independent variable. In this case, if you see, there is one independent variable and one dependent variable. So this is called a univariate regression. Now, if you have an equation that y equal to m1 x1 plus m2 x2 and so on, where you have multiple independent, please note that there is always one dependent variable in the case of supervised model, but there could be n number of independent variables. This is called multivariate regression. And one of the classical examples of multivariate regression is, for example, if you want to predict house price, you're going to predicting a house price. Your house price prediction could be based on multiple factors. It could be number of rooms, area, whether it is a new flat or a resale flat, number of area, whether then it could also be proximity to the mall or proximity to the airport, whatever, railway station, right? So all these factors will determine the house of the price, and this case your predicted house price becomes the y. This becomes your independent. This is x1, x2, x3, and this becomes x4 and so on. So this is an example of a multivariate regression. But imagine you have historical data having multiple independent data variables. Ma'am, can you please go on mute, please? It's very disturbing. Thank you. So when you have multiple independent variables like x1, x2, x3, x4, okay, we call it a multivariate regression, right? So if you have such historical data, right, then you can use algorithms to predict a house price for any new set of combination of these values. So if you have a number of rooms, area, if you give, as I told you, you have got training data and test set, right? So when you feed a new set of data from the test set, it will predict the house price automatically through the machine learning model, right? So this is an example of a multivariate regression. So when you talk about, okay, this is one type. The second type is when you talk about y equal to mx plus c, but here the y is a discrete variable. When you say a discrete variable means it will have a fixed set of values. That means it could either have yes or no, or 0 or 1, or it could have a fixed set of values, but it will not have an infinite or continuous value as we had in regression, right? In such a case, that's this sort of data, we call it classification. So you have a dependent variable, you have independent variables. The difference between regression and classification is regression, your dependent variable is continuous, while in classification your dependent variable is discrete. Okay, having a specific set of values. So in classification, so for example, if I take a classical case of this is whether a person is suffering from cancer or not. So this will have two values, yes or no, right? And then what could be the x1, x2, x3? It could be the various tests. This becomes y, and these are the various tests that will determine whether a person is having cancer or not, right? So this is an example of a classification. So you have a regression with a continuous variable and a classification with a discrete variable. Okay. So when you talk about supervised model, you have regression and you have got classification. Any questions till now? Any questions till now? I hope I'm audible. Somebody saying sound not coming. Yeah. Can I get a quick yes or no on the screen? Have you understood what is supervised model? Okay. Good. Very nice. Thanks for the response. Now we will go to the next one, what is called the unsupervised model. Now I will not get into details of this because this is itself a very complex, because our focus today will be more on the classification and regression, which Kiran sir will demonstrate. Okay. But just to give an example, so in case of unsupervised model, with the very definition that you can think about, unsupervised is something which is not supervised, right? That means, first of all, there is no question of dependent and independent variable. That means there is no dependent variable, there is no independent variable in unsupervised learning. But in unsupervised learning, you have data and you have algorithms which will try to derive patterns out of the data automatically. So the patterns in the case of supervised model, the patterns were already known because you have a dependent and independent variable. But in the case of unsupervised model, there is no dependent variable. So you don't know what is the pattern. So you need algorithm which will derive the pattern out of the data. That is what is called unsupervised algorithms. And the classical example which I want to highlight here, which you must be using day to day in your day-to-day life, is what is called a recommendation system. Now, what is a recommendation system? If you go to Netflix or if you go to Flipkart, you buy a movie or you buy a product. Now you must be seeing a recommendation engine, right, which comes and says, okay, Arunjit, why don't you see this movie B? Or Arunjit, why don't you buy this product B? Right? So this is an example of an unsupervised model where I'll just give an example how this works. Okay. Now let's say me and Kiran sir, we are two people. We watch a lot of movies of Netflix, right? And we basically like to watch all basically movies where there's a lot of violence and fights and all that, right? And we have similar profiles. So typically when you in a recommendation system, every person will have a profile. So his age, what sort of movies he likes, right? So his profile and all that. So if Kiran watches a movie A, okay, ABC for example, and Arunjit watches a movie DEF. So what the recommendation engine will do is it will go through all these similar based profiles and it will recommend. So it will say, Arunjit, why don't you see ABC? And it will probably say, ask Kiran, why don't you see DEF? Right? So it looks at similar based profiles. There are various parameters which can be identified in recommendations, but I'll just give you a very simple example. So it looks at profiles and tries to recommend movies or products based on the similar behavior of the persons, right? So this is how a recommendation engine works, and that's where we use what is called the unsupervised algorithm, because here there is no concept of a dependent or an independent variable. There is no concept of a dependent or an independent variable. Okay. So this basically talks about machine learning and its various types, right? Now let's dive into what is called deep learning. Now this is a very important term. Now again, this is also called neural networks, which is similar to how your brain neurons, right? It works on the same architecture. We'll not get into that architecture now, but I will try to tell you where it is used. Deep learning is mainly used for identification of images. And I will take you a very simple example. You have an electronic equipment or any equipment that you make, right? Or could you have a circuit board, and you are manufacturing a circuit board and you are trying to find out whether that particular circuit board manufactured has a defect or not, right? So using neural networks or deep learning, what we can do is we can capture all the defective and non-defective circuit boards. I can create a historical data, right? And then what I do is I feed in that into a deep learning algorithm, and again the same concept. It will derive a patterns. It will try to predict for a new set of data and give you an accuracy, right? So image identification is one of the very important one of the important features which is part of deep learning, right? And we also we call it artificial neural networks. There we also called it a convolutional CNN, convolutionary neural networks. Convolution neural networks, okay, for identifying images. Okay. So various types of basically non-text data, could be images, could be videos, could be any other types. They can be or voice. Okay, they can be basically captured, and you can use machine learning algorithms, using deep learning algorithms to derive basically patterns and detect some outputs. Okay, and the third, which is happening today, is what is called the generative AI. And all of you must be hearing this word every now and then, right? Generative AI is basically, we talk about chat GPT, right? When you talk about chat GPT, we always talk about, it's all linked to generative AI. How many of you are using chat GPT? And for what? How many of you are using a chat GPT? How many of you are using chat GPT? Come on guys, if you don't use chat GPT, it's a problem. Please raise your hand or say yes. Have you used chat GPT for genetic research papers? For what purpose? Patruni, go ready. For what purpose you're using it? Can you just highlight? That will be good for all of us. It's good that, yes, for what purpose, anybody can tell me? Because the utility is vast, but it should be specific to your interest, right? So I just wanted to know for what, in which specific area you're trying to use it for. For notes and questions, to get brief information of a concept. Okay, very good. Subject related, very good. Okay. So it could be used in various types, and so chat GPT, there are various, so generative AI, when you say chat GPT is one of the, there are various other tools that is called, this is from OpenAI. So basically what it does is, you ask a question, it gives an answer. the question could be anything. It could be, the answer could be a text, the answer could be an image, the answer could be a picture or whatever, right? So you also have got tools like Gemini from Google. You have something called Llama from Meta, which was earlier Facebook. So there are various models which a lot of industries are coming out with, and today a lot of people are moving towards generative AI. There's a lot of craze about it, right? And in fact, it's become so easy for students that it also generates code for you. So people who are from computer science students, right, automatically, you write a particular, you say, please generate a code for me for this use case. It will generate Python code for you. I mean, that's so easy, because sometimes I feel that it is easy, but people have stopped thinking. People have stopped thinking to code. Okay, but that is again the interest in it. Now industry wants a project to be implemented quickly, right? So obviously today ChatGPT becomes very easy for people because it generates code and it can implement that code very quickly, right? So there are various pluses and minuses, but overall, yes, there has been a lot of improvement with ChatGPT or with generative AI coming in. Okay, fine. So this covers machine learning and deep learning. So let me get back to the slide. So basically, if you see this definition, a computer program is said to learn by experience by detecting patterns from the historical data and doing predictions for future-based data based on learning experience. The same thing which I told you through all the steps. I've tried to explain it with a single line. Right? There are various definitions. Now, Arthur Samuel and Tom Michel are the pioneer or the inventors of AI, okay, and machine learning. Right? This is what is all about, right? So you have AI on the outer part. You have machine learning, which is a subset of AI. You have deep learning, which is a subset of machine learning, and generative AI, which is part of deep learning. So please understand one thing. You need to know, first of all, there are 3 levels you need to know. So level 1 is machine learning, level 2 is deep learning, and level 3 is generative AI. So these 3 levels are very, very important. And these are all prerequisites. If you don't know level 1, you won't understand level 2. If you don't know level 2, you will not understand level 3. And when EBTS as an organization, when we teach the students, we teach the students level wise. We first start with level 1, then we go to level 2 and go with level 3. Now if somebody asks me, can you teach a student generative AI? I will first ask, does he understand what is deep learning? Does he understand what is computer vision? Does he understand what is CNN, ANN? Right? If he doesn't understand that, then he will not understand even generative AI. So these are all prerequisites for becoming an expert in AI. Okay. So this is an example of a regression which I already told you. I spoke to you about price of a house. It could be a price of a car, which could depend on various factors. So you have a dependent variable and independent variable. This is an example of a classification where you have various independent variables here, and the dependent variable is the class, which could be a mammal, reptile, fish. So there are only fixed values, either mammal, reptile, fish, amphibian, or bird. There are only 5 types. Okay, there are only 5 output types, or we call it labels, right? So this is a example of a discrete the example of classification. So for example, so this is an example, yes or no. Whether it's yes or no, it's going to be a classification. Will the tire fail in the next 1,000 miles? Yes or no? Okay. What is the defect in the new batch of gears? Okay. Whether it's a crack, scratch. So there are different types. Whether it's a crack or a scratch or a deformation. These are examples. This is an example of a classification. This is what Kiran sir is going to show you. Is that you have a circuit board which is a damaged or a non-damaged. I told you earlier, right? So using machine learning algorithm tool, there's a tool called Google Teachable Machines from Google. You can just automatically detect whether a product is defective or not. And he will show you with the examples. Similar in regression, you have similar case. Now let us go to some use cases. Now before I talk about use cases, these are various use cases. But always remember one thing. The crux is the same. For any application of machine learning, whether it's in electrical industry, whether it's in electronic industry, whether it's a civil industry, whether it's a mechanical industry, you need to have historical data, first of all. You need to have historical data, you need to have algorithms which will derive pattern and then predict. Without this, you cannot do any applications of this. So all these applications are based on historical data. Always remember that, right? So you have fault detection and diagnosis. So you want to have a fault detection. Okay, if there's a fault in a particular in a circuit board, or if for any equipment, right? So you need to have historical data, and it will detect. Okay, it can find out faults for a new set of data. Predictive and preventive maintenance. So if you have an equipment, you want to predict whether a machine is going to fail in the next 10 days or 12 days, or preventive maintenance. How soon you should start making some corrections, or basically arrange for an annual arrange for maintenance, maybe in 3 days, 5 days of machine. This all can be done using machine learning algorithms. Energy consumption forecasting. So if for example, this is something which Kiran sir will show you. Now you have a meter reading, right? Okay, now if you have a consumption of electricity for the last 12 months, okay, using machine learning algorithms, you can forecast what could be the consumption for the next 12 months, 24 months, or 36 months. So you can find out the trend of the consumption, right? Then anomaly detection, voltage patterns. So again, if there's a voltage pattern detection, it can, through historical data, it can detect and give you some analysis. Grid optimization and load balancing. Smart meter data analysis and issue identification. So today you are using smart meters in everywhere, in a lot of industries. So you implementing smart meters, and the data captured from the smart meters, you can find out if there are some issues, and you can try to rectify those issues, right? Energy efficiency in buildings for better load management and reduce waste. Okay, so how you can manage the energy efficiency in whether commercial buildings or residential buildings to reduce the waste and basically better load management. Customer segmentation. Now you are basically into sales, and you are selling products to your various types of customers. Now, depending on the category of customers, depending on the customers giving you revenue, you may have A-class customers who are giving you the maximum revenue. You have B-class customers who are giving a moderate revenue. You may have a C-class customers who are giving a low revenue. So you could classify these customers based on machine learning models. And demand planning. So demand planning, again, if you have a raw material which are used for manufacturing a circuit board, and if you know what is the consumption for the last 12 months, you can also find out what is the forecast for the next 12 months, like that. The similar case for electronic industry: circuit design optimization, predictive behavior of electronic systems, defect detection of printed circuit boards, predictive and preventive maintenance, supply chain optimization. How do you optimize the supply chain right from manufacturing to logistics? Automated inspection, that is quality inspection. Detection in product behavior, if there is an anomaly detection of product behavior. Power electronics, how do you optimize power converter designs? Signal processing, how do you improve the noise? How do you reduce the noise, or how do you improve the noise cancellation? So these are the various applications where there are umpteen applications of machine learning in various industries. And today, what people are, now this is where I'm going to get into. Today, the apprehension of most of the students, whether it's electrical, mechanical, electronics, or civil, right? Well, today I've seen a lot of electronic students, electronic and communication, getting into IT. I've seen that because we are all from the industry. I've seen people. So people generally join computer science, or people from electronics also get into IT, right? Now, people who are from core engineering, they feel that, okay, why should I get into machine learning? There is so much of coding required. I have to first of all know a programming language called Python. At least you should know. Python is a very common programming language. I should know Python. I should know what is libraries. I need to know the syntax. I need to learn the programming aspect. Now, today, what is happening, unfortunately, is that many of the colleges, they are including Python as a subject for mechanical engineering. Okay, because then they can learn ML. This is something which we need to realize, that if you are getting into an industry and you want to pursue machine learning as a career, there is no need for you to do programming. Understand that. You need remove the apprehension that if I want to get into machine learning in industry, I need to have some Python programming knowledge. Not required. It's absolutely not required. So when you're talking about automated machine learning, what is automated machine learning is today the industry there are today companies are smart. The lot of vendors, they are coming out with some auto machine learning tools. Now, what that auto machine learning tools does is that, see, earlier I used to write lots of coding, or even if I'm a computer science student getting into an industry, I will write some code in Python and then execute some machine learning algorithms, right? But in AutoML, it is zero code. What that means is that today the tool is doing everything for you. You don't have to do the coding. So you take an AutoML tool. What you obviously need to understand is what is machine learning. You need to understand what is supervised learning, what is unsupervised learning. You cannot get, you need to understand the data, right? The historical data that is given to you you are a domain expert. You understand the domain of electrical, you understand the domain of electronics, right? Or it could be civil mechanical. So if you understand the domain of historical data, you can find out whether it's a classification, regression, or it is an unsupervised model type, whatever, right? So your domain knowledge plus your machine learning knowledge is good enough, and understanding of algorithms is good enough for you to become a very good data science engineer in that specific industry. And you don't need any coding knowledge, right? So today the industry is moving from heavy code, when initially we used to do a lot of C program coding and all that, to a low code, which is in today in machine learning parlance. We write, when you're writing code in machine learning to execute a machine learning algorithm, you're maybe writing 500 to 1000 lines of code. But when you get into AutoML, there is no code required. You don't need to write a single line of code. It is absolutely zero. You don't need to understand what is going on behind the tool. The tool is doing everything for you. What do you need to know? You need to understand the domain. So you need to understand the domain knowledge. You need to understand the historical data. You need to understand what is the business objective. Why are you using machine learning models? Okay, you use the AutoML tool and then you deploy it at the client location depending on the model accuracy, as I told you. So an electrical engineer will be able to bring valuable domain expertise that is critical in machine learning engagement. So AutoML automates the process of building and deploying machine learning models, right? So today AutoML, if you look at, there are so many AutoML tools. There is something called Power BI from Microsoft, which Kiran sir will demonstrate. You have got Amazon SageMaker. You have got Azure Machine Learning, Google AI. So Google, as I told you, has got another tool called Google Teachable Machines, which again Kiran sir will demonstrate. It's such a wonderful tool. You don't need to write single code, and it shows you how to do image detection. These are some other tools, and another tool which is missing here is skinning. And if time permits, we have time till 12 o'clock. If time permits, we will just glance through that K9 tool if we have time. But we'll show you some demo. So there will be two demos which we'll show you. Number one, we'll show a regression function, regression data, where you have basically one is we'll have a regression. Second, we'll show you a classification. So regression will be the demand planning, and classification will be defect object detection, whether it's a defective or non-defective, right? And if time permits, we will show you one third use case. Any questions before we get into the demo? While Kiran sir will, I'm just stopping sharing while Kiran sir prepares himself for the demo. Any questions? Any questions? Can I get a quick yes or no if you have understood everything? If these concepts are clear, is very important. Okay. Fine. So Kiran sir, can you please take over? While before Kiran sir demonstrates, how many of you have installed Power BI? Have you installed Power BI in your machines? Okay, I am presuming you have installed Power BI, and in the email to HOD ma'am, I'd also sent one link to a Google Drive. I hope that link is available to you because that will be used for this. So I had sent one demand planning.csv file, which was an attachment that will be used in the first use case in Power BI, and the second use case we had sent one link to a Google Drive. I hope you have got access to that Google Drive because that will be used for the second use case. Yeah. Okay, Kiran, please take over. Thank you.
Yes. Okay. So good morning. So today we will be seeing the first use case. Am I audible?
Yes, you are audible. Yes, yes.
So today we will be first seeing the the first use case, that is the demand planning.
1 minute. Hello, can you please go on mute? Admin, can you please put others on mute? Thank you. Yeah.
Okay.
Yeah.
So here, so let's assume that you are working for a company, and in that company there is a certain product where each for every day a certain sales is being expected or certain sales has been done units. So what we have the data here is you have a certain demand for that specific product on a certain date. So that is what this data represents. So let's say that you have like for a data X, you have 9.5 units of demand on 1st January 2013. Likewise, you have a demand of 8.5 units for that specific product X on the date of 2nd January 2013. So likewise, you have
Kiran,
all
can you
the
please
demand.
expand it? Kiran, can you please increase the font?
Yes.
And you can talk about consumption of power units. That is better, correlating, not sales. Power
Yes.
consumption, or yeah.
Okay. So for that specific date, what is the like the specific consumption in terms of units? So this is the data. So we have two columns. One is the date, and the other is the specific units that has been consumed on that specific date. So going by this data.
1 minute, Kiran.
Yes, sir, you're on mute, sir.
Sorry. Can you keep the data, show the data, please, Kiran? Yeah. So I want you all to tell us what sort of data is this? Is it a regression data, classification data? And if it is a regression or classification, which is the dependent variable and which is the independent variable? So Kiran sir has told there is a date and there is a consumption of units, whether it's a electrical units or energy units, whatever. So you need to tell me which is the dependent variable and independent variable. See, first of all, you need to understand the data and then the problem statements. We'll come to the problem statement later. First, you have to understand the data. What is the data? Can somebody tell me what type of data is this? If you don't understand this data, then when Kiran sir shows something, you will not be able to correlate. The basic fundamental should be clear here. Yes, please respond here. What type of, is it regression or classification? Number one, and number two, which is the dependent variable and which is the independent variable? Pila Deleshwari, you are saying regression. Okay, then which is the dependent and independent variable? Date is independent, Y is independent. Very good. So this concept has to be clear to all of you, right? So what Kiran sir is going to do is he's going to predict. First of all, he will train the model and then he will predict for a new set of data what will be the forecast for the next 12 months, right? Using the machine learning regression algorithm. Yes, Kiran. Thank you.
So this is the tool. So this is the Power BI, which is developed by Microsoft. So yeah, so the first part is I will be so there is, as soon as you open the tool, you will find an option called as blank report. So you need to click on blank report. So here, the moment you click on that blank report, a new page will open, which will have the canvas where you will create your dashboard or the reporting page. And on the right hand side, you have multiple plots where you will visualize your data using these plots. And on the far more right, you have another column called as data, where this represents or indicates like which data has been imported into your tool. So first what we will do is we will import the data. So for that, what we do is under the home option, you have an option called as get data. So I repeat, under home option, you have an option called as get data. Click on that. So you'll have different formats in which the data is present. So here I select the text/CSV. The moment I select that, I will click on the data where I have stored in my local hard drive, that is demand planning. I'll click on that and I'll click on open. So here the moment I do the open selection, here it will give me a prompt asking me to confirm the data. Whether is this the data which I intend to import into the tool. So yes, the data which I want has two columns, that is the date and the consumption. So these two columns is what I want. So I'll load the data. Okay, so the moment the data has been loaded on your far rightmost side, you can see that under the data column, the demand planning data has been imported. And under this, when you expand this data, you have again the two columns where the date is again, it's again segmented into year, quarter, month, and day. And you have the demand. Now, let us build the canvas. So first is let us put a text here. Let us add a title. So I'll go to a text box. I'll click on the text box. And let's say I write here demand planning. I'll increase the font. I'll make it bold. So this is how we write a heading. And then when you see the visualization section on your right hand side, when you see the visualization section, the second row and first column, you see there are multiple plots here, right? Small icons. In that, the second row, first column, that is the line chart. So I click on the line chart. So the moment I click on this plot, I get an empty plot here. I'll enlarge the plot here. So here I need to declare the X and the Y axis. So X axis will be the time and Y axis will be the demand or the unit consumption. So here X axis I'll put the year and Y axis I'll put the respective demand. So the moment you add the X and the Y axis, you get the graph. So what this graph indicates us? So this graph indicates there are totally 7 years and what is the sum total of the consumption or the demand for that particular year. So in the year of 2013, a total of approximately 2,854 units has been consumed or demanded. Likewise, at the year of 2014, 2,889 units were demanded. So likewise, we have it for 7 years, that is 2013 to 2020. Now the objective is using this data, using this information, how will we forecast the demand for the next 3 years or 4 years? That is the objective here. I repeat, in order to predict using this data, we will try to predict or forecast what will be the demand for the next 3 to 4 years. That is the objective here. So in order
Kiran,
to
1 minute. Kiran, can we just check how much they have done on this? Have you guys done something? Have you come till this stage, all of you who have got Power BI installed on your laptop or desktop? So all of you have come to this stage. Kiran, can you share your screen? Yeah, keep your screen shared. Remove it, yeah. Have you guys come up to the stage? Okay, Kiran, you can go ahead. Thank you.
So here, in order to start with the visualization, like with the data forecasting, I click on the plot. The moment I click on this plot, under the visualization tab, you have three icons. So go to the last icon, which represents like a magnifying glass, right? So go to that icon, click on that icon. So the moment you click on this icon, you have multiple options. Select the forecast option, which is present at the last but one option. So I repeat, in the visualization bar, there are three icons. Select the magnifying glass icon. The moment you select magnifying glass icon, you'll have multiple options. In that, select the forecast option, which is there on the last but one option. Switch it on. So the moment you switch it on, you see that the data has been by default forecasted for the next 10 years by default. So that is from 2021 to 2030. The data has been forecasted. But you observe here that the forecast is almost or it is constant, right? So if you see at the year of 2021, the demand is 2707 units. Again, 2022 it's 2707.30. At 23 again 2707.30. So what you observe here is for the entire 10 years, the demand is predicted to be accurate or constant up to the 2 decimal points, which is very unlikely in real world incident, right? Like it is not going to happen. So what this estimation or what this prediction lacks is seasonality, which means that we need to segregate the data into different seasons and take those seasons and then try to predict. So what we will do here is under the forecast option, you have like multiple options, right? You have units, forecast length, ignore the last and seasonality. So I'll select the seasonality. I'll increase it up to 4 years. So what it will do is it will take the samples of every 4 years and that as a batch it will try to predict. So that is seasonality. So I'll add the seasonality up to 4 years and I'll decrease the forecast length to let's say 3 years. Now the reason why I'm doing this is we have the data only for 7 years. So using only 7 years of data, we cannot predict for the 10 years of data. It's very unlikely. So always the retrospective data or the past data, the historical data should be higher than the data we are going to predict, the samples. So if we have for only 7 years, it's safe to assume for only half of it, let's say for 3 years. So that's why we have selected 3 years. So here we have changed the forecast length up to 3 years and the seasonality we have added up to 4 years, 4 points, and we apply. So now you see that the variation has come and it is it is kind of reflecting the four parts, that is from 2013 to 2017, then again from 17 to 20. So these two parts it has taken and it has tried to predict. So now we can see that the demand for 2021 is 2867 and it's for 22 it's 2735. So it is kind of based on the historical data of the 7 years, it has predicted for the next 3 years. So this is how we try to predict the data using the regression. Any questions?
So have you guys understood what we have done? See, what we have done is we have done based on the data, we have done the forecast, and then for future 4 years, we have done the prediction. Again, using background, then we're running some algorithm. If I would have done this using Python code, I would have to write at least 550, 100, 200 lines of code, which is not required here, right? So everything is done automated. So this is just one of a simple example of a regression. There could be multiple such examples, but understanding the concept is very, very important here. So have you guys understood? Anybody? Some of you can try it out. Have you tried it out? It's very simple. It's a very easy tool. You have got the CSV file also, demandplanning.csv, which I had given it as part of the email as a deliverable. Have you guys understood? Yes or no? Can I get a quick yes or no? Can you please respond on chat? Would you please explain after declaring X and Y variables? Kiran, can you just go through that? Yeah.
Yes, sir. Okay, so let's say this is the plot, and we have declared the X variable here with respect to year, and Y variable is with respect to the demand. So here we have the plot where X is the year and Y is the demand for the total demand for that particular year. For 2013, what is the total demand of units? That is what we have. Likewise for 2014, right up to 2020. Now, our objective is to forecast or to predict the data, the demand, what will be the demand for the next 3 or 4 years. So, for that, under the visualization option on your right hand side, you have a visualization option, right? Column. In that, select the magnifying glass option. So, there is a icon indicating a magnifying glass, right? Select that. Click on that. The moment you click on this option, there is an option right at the bottom called as forecast. Under the magnifying glass icon, you have an option called as forecast. So switch it on. So once you switch it on, you need to add seasonality in order to avoid this constant. So because this kind of estimation is very unlikely in real world. So for that, in order to, so what this lacks is seasonality. So you need to add seasonality. So under the forecast, under the options, the fifth option called as seasonality. Sorry, the fourth option. I'll add 4 points, which means that it takes the block of 2013 to 2017 as one block and then 17 to 20 as another block. Based on these two blocks, it will try to predict. And the second parameter, what I will be changing is the forecast length. So this basically says that 10 indicates the forecast for the next 10 years. But since we only have the data for just 7 years, we cannot predict it for 10 years. So I'll reduce it to, let's say, 3. So now I'm predicting only for the next 3 years, and then the seasonality I've included up to 4 points. Now when I click on apply, I get the prediction with the considered seasonality of the historical data. So here I can see that in 2021, the estimated forecast would be 2,867 units. And in 2022, it has decreased to 2,735 units. So likewise, you get the seasonality. We can predict with a certain seasonality based on the historical data. I hope it is clear.
Yeah, Pilala Dileshwari, ma'am, I hope it's clear to you. Yeah, it's done. Yeah, okay, fine. Let's go to the second. Now let's go to the second use case, Kiran sir. Yeah.
Okay. So the second use case is on the image classification. So before starting that, let me just share you the link. Okay, or else before, let me explain the data first. So here we have solar panel data set where we have clean solar panels. So we have images. So you can see the images here. These are all the images of solar panels, and these are all very clean. The panels are identified as clean solar panels, which means that it does not have any kind of defects or dirt on the solar panels. It's clean. Likewise, we have another data called for electrical damage. So some of the solar panels have some sort of
Ma'am, can you please go on mute? Yeah,
So
Kiran?
secondly,
Yeah.
we are taking solar panels which have some kind of electrical damages to it. So these are some of the electrical damages, what you see. So the